Okay, so in this video we're going to be going over the octahedral shearing stress theory, which is also known as the von Mises criterion. Basically what this does is it predicts failure of a structure or an element or anything when the octahedral shearing stress at a point achieves a certain value. This value is found using this equation, and it relates the octahedral shearing stress to the yield stress here by this equation. Basically all you have to do is find these stresses here, which can be found fairly easily, and plug it into this equation and then plug it back into here, and that'll give you your max, that'll give you your yield stress, sigma yp there. So I'm going to do an example here to make this a little easier to understand. This was the same example from the last video with the maximum shearing stress theory. So we have this stress matrix here, and it's asking us to determine the tensile yield strength using the octahedral shearing stress theory, or the von Mises, and we're going to assume it's uniaxial. So we found in the other video that, can you see that? Yeah, what's going on? That the max stress is equal to 151.104 MPa. Sigma 2 is just 0. And the minimum stress is equal to negative 61.104. Okay, so from here we plug it back into this equation here, right there, with these values that we found from the last video. So we plug it in to this, sigma 1 squared, sigma 2 plus and you just plug these into here, and you get the octahedral shearing stress to be 89.19. And then we just plug that back into this equation here, because that's what this criterion is. It just relates the octahedral shearing stress to the yield stress. So we plug that into this right here, and then rearranging, we just get that octahedral shearing stress over 0.7. Oops, that should be sigma yp. Sorry about that. And that is found to be 189.77 MPa. It's equal to the yield stress at this point here. So basically that's also a pretty basic method, and it's used to find the yield stress at a point given. Thanks.